Before starting with exercise 16b, let's know few theorems. Say for example, if there are two similar triangles, okay, it's proof that there are two similar triangles. Then the theorem says that if there are two similar triangles, then the area of both the triangles which are in a ratio form, it is equal to or it is proportional to the squares of their corresponding side. What does it mean? Say area of triangle ABC upon area of triangle PQR. Okay, the areas of two similar triangles are proportional to the squares of their corresponding sides. So if I take side AB, so AB square upon PQ square, either it is equal to this or it is equal to BC square upon QR square or AC square upon PR square. So the area of two similar triangles are proportional to the squares of their corresponding sides. This is theorem 3. Then comes theorem 4. Okay, it says that if AM and PN, they are the two altitudes, then area of two similar triangles is proportional to the squares of their altitude. That means AM square upon PN square. What are altitude? Altitude means height. It forms 90 degree or they are perpendicular. Okay. Then comes theorem 5. Theorem 5, instead of being perpendicular, say they are equal. So when these sides are equal, what do you mean? AM will become a median and PN will also become a median. Median intersects the line segment into two halves. So theorem 5 says that area of two similar triangles is proportional to the squares of their altitude. This is an altitude. They are squares of their altitude. This is equation 5. Then comes area of two similar triangles. Area of two similar triangles is also proportional to the line, the segment which cuts the angle into two, which is also called as angle bisector segment. Say for example, AM bisects both the angle equally. Here also PN bisects both the angle equally. So it is also equal to angle bisector segment, square of angle bisector segment. Here once again we'll revise. The areas of two similar triangles are proportional to the squares of their corresponding sides, to the squares of their altitude, to the squares of their median, to the squares of the angle bisector segment. Okay, come on, let's start with exercise 16b. Let's read the first question from exercise 16b. It's given that DE is parallel to BC. Okay, I have to prove that triangle ADE is similar to triangle ABC. Let's prove that. First part. So in triangle ADE and triangle ABC. Now smaller triangle and a bigger triangle. What is common? Angle A is common. So you will first write angle A is equal to angle A, common angle. Then since these two sides are parallel, so this angle and this angle will be equal, corresponding angles. So angle ADE is equal to angle ABC, corresponding angles. Corresponding angles are equal, right? So therefore triangle ADE is similar to triangle ABC. Both are angles. So by axiom test of similarity, you write the entire thing. This becomes your first part of the answer. Second, given that AD is equal to DB. What is given? AD is equal to half DB. Okay, you have to calculate DE if BC is 4.5. Now you have proved that this triangle is similar to this triangle. correct? Now DE you have to calculate, BC is given, and this one hint is given. So this will become 2AD is equal to DB, correct? Now if I take, since the triangles are similar, I can use the basic proportionality theorem, which says that AD upon AB is equal to, you want to prove DE, you have to find DE upon BC. Okay. Now what is AB, children? AB is what? AB is AD plus DB, correct? Now what is DB? DB is 2AD. So this will become AD plus 2AD. So AB is 3AD. You will substitute this value in the basic proportionality theorem. Okay. So AD upon 3AD is equal to DE, you have to calculate, upon 4.5. AD and AD gets cancelled. What is left here? 1. So DE is equal to 1 into 4.5 divided by 3. 1.5. So DE is equal to 1.5 centimeter. Clear? Yes. Now the third part, you have to find the area of triangle ADE, and area AR represents area, and area of triangle ABC. Since you have already proved that the triangles are similar, what was the theorem? The areas of two similar triangles are proportional to the square of their sides. So the third subpart, area of triangle ADE upon area of triangle ABC, which two sides are given. DE you found out, which is 1.5, and this is 4.5. So you can take these two sides, corresponding sides. So this will become DE square upon BC square. It is equal to the square of their corresponding sides. What is DE? It is 1.5 the whole square upon 4.5 the whole square. Now children, to check whenever you have to find the square ending with 5, I have already posted a short where you will find an easier way to solve this. So this will become 1.5 the whole square will be 2.25 upon 4.5 the whole square would be 20.25. Now but you can't leave the answer in decimal, you will have to reduce it. Come on, let's do it here. So area of triangle ADE upon area of triangle ABC is equal to, both have two decimal places, you can remove the decimal place. So 225 upon 2025. 5 4s are 22, 5 5s are 5 4s are 0 5. Okay. Now in 45 table I know 5 9s are 581. So this will become 1 upon 9. So the answer, the ratio is 1:9. This is the third subpart. Now let's do the fourth subpart. What have they asked in the fourth? You have to find the ratio of area of triangle ADE and the trapezium. They have asked you this trapezium. How will you get this trapezium? Area of triangle ABC minus ADE. When you do, you will get this trapezium, right? Let's follow that. What information you have first? Write it down, that area of triangle ADE upon area of triangle ABC is given. You got it as 1 upon 9. Okay. Now simple way I am teaching you, whenever you want to find the trapezium or a quadrilateral, you will do subtraction of 1 on both the sides. But the rule is, how will you get this? When a bigger triangle subtracts a smaller triangle. So always remember, the bigger triangle should be on the numerator's place. Okay. Now over here the smaller triangle is in the numerator's place. So let's take the reciprocal on both the sides. So this will become area of triangle ABC upon area of triangle ADE is equal to 9 upon 1. I took the reciprocal. Now, what trick did I teach you? Whenever you want to find area of trapezium or quadrilateral in this triangle, you will always subtract 1 from both the sides. So, if I subtract 1 from both the sides, say area of triangle ABC upon area of triangle ADE minus 1 is equal to, this is 9 minus 1. What I have done? I have subtracted 1 from both the sides. Okay. Now you take the LCM over here. When you take the LCM, what you will get? Area of triangle ABC upon area of triangle ADE. This is minus 1, so you will multiply with this, minus area of triangle ADE the whole upon triangle 1, because both LCM is this. And this will become 9 minus 1, which is 8. Now see, we got the answer. Area of triangle ABC minus ADE. What are you getting? You are getting trapezium BCED. So area of trapezium BCED upon area of triangle ADE is equal to 8. But what was in the question? The question was, the triangle is up, the smaller triangle is up, and the trapezium is in the denominator. So what you will do? Again you will take the reciprocal. So when you take the reciprocal, area of triangle ADE upon area of trapezium BCED is equal to 1 upon 8. And this becomes your fourth part of the answer. Yes? Come on, let's go to the next one. Let's go to question number 4. AB is perpendicular to BC and DE is perpendicular to EC. And the measurements are given to you. You have to find the value of AD. First, before taking anything, any measurements, what you have to prove? That the triangles are similar. Which two triangles will you take? Triangle ABC and triangle DEC. In triangle ABC and triangle DEC. First, both are right angle. Angle ABC is equal to angle DEC by, both are 90 degree, right? Both angles are 90 degrees since both are perpendicular. Then angle C is a common angle in both. It's a common angle, correct? Therefore, these two triangles, triangle ABC is similar to triangle DEC by axiom test of similarity. Okay, this part is done. Now let's use basic proportionality theorem. So AB upon DE is equal to, what you have to find? AD you have to find. So what other AC is given to us, right? So AC upon DC. AC upon DC. Now over here what you will do? Let AD be X. Let AD be X. If AD is X, what would be DC? DC would be 24 minus X, because AC is 24. Let's substitute this. AB is 9 upon DE is 3 is equal to AC is 24 upon DC is 24 minus X. Okay. This you can reduce 3 times. Now cross multiply. So 3 into 24 minus X is equal to 24. Okay. Take this 3 to the other side. 24 minus X is equal to 24. Divide by 3. Okay. Which is 8. 3 8s are. So 24 minus X is equal to 8. Now take 24 to the other side. Minus X is equal to 8 minus 24. Minus X is equal to minus 16. So X is equal to 16. So you have to find AD. AD is 16. Let's do question number 5. It's given that DE is parallel to BC and the measurements are given. Measurement is DE is 4 centimeter, BC is 6 centimeter and area of triangle ADE is given as 20 centimeter, you have to find the area of triangle ABC. Children, whenever you have to find the area of triangles, remember the theorem. Area of two similar triangles are corresponding to the square of their sides. But first thing, you will have to prove that these two triangles are similar. Okay, the first part is in triangle. Which triangle will you take? DE measurement is given, BC measurement is given. So you will take in triangle ABC and triangle ADE, because DE and BC measurement is given to you. Okay, so what is it? Now both are parallel, that means this angle is equal to this angle, corresponding angle. Angle ADE is equal to angle ABC, corresponding angles. Children, whenever you are making use of corresponding angles, alternate angles, you can make use of it only when two sides are parallel to each other. Okay. Then angle A will be common in both. Angle A is equal to angle A, common angle. Therefore, triangle ABC is similar to triangle ADE by AXIM test of similarity. This part is done. You have proved these two triangles are similar. Now let's use the theorem. Area of triangle ADE upon area of triangle ABC. Areas of two similar triangles is proportional to the square of their corresponding sides. So DE square upon BC square. Okay, what is the measurement given for ADE? It is 20. So 20 upon area of triangle ABC is equal to, what is DE? DE is 4. So 4 square upon 6 square. So this is 20 upon area of triangle ABC is equal to, what is 4 square? 4 into 4, which is 16, and 6 square, 6 into 6, which is 36. So area of triangle ABC will be equal to, cross multiply 20 into 36 divide by 16. Okay. Now let's simplify. 4 4s are, 4 5s are, 4 9s are. So answer is 5 9s are 45 centimeters square. Don't forget to put the unit square, otherwise it will go wrong. Okay, chalo, let's go to the next one. Let's go to question number 7. In triangle ABC, the measurement of AB is given, angle B is 90 degree given, AC measurement is given. If D and E are the points on AB and AC respectively, such that angle AED is 90 degree, DE is 3 centimeter, I have to prove that triangle ABC is similar to triangle AED. The first sub question, in triangle ABC and triangle AED. Okay, since both these two are 90 degree, so angle AED is equal to angle ABC, right? Both are 90 degree. Okay, next, what is the other condition? AED and ABC, angle A is common, so angle A is equal to angle A, which is common angle. Therefore, triangle ABC is similar to triangle AED by AXIM test of similarity. We have proved the first one. Okay, now the second one I have to prove it. Area of triangle AED is 6 centimeters square. You have proved this two triangle. Now, what is the theorem? Area of both the triangles, two similar triangles, is equal to the square of their corresponding side. So, area of triangle AED upon area of triangle ABC is equal to AED, you can take as DE square, and ABC corresponding it would be BC square. This is what you want. What things you don't have? You don't have area of triangle ABC. You don't have BC square. So first thing you will find these two. What is area? First let's find BC. Now this is a right angle triangle. You can use Pythagoras theorem. So by Pythagoras theorem, what does Pythagoras theorem say, children? It is always hypotenuse square. What is hypotenuse? The side which is opposite to right angle. So AC square is equal to AB square plus BC square. Correct? AC is 15 square is equal to 12 square plus BC square. 15 square is 225. 12 square is 144. It comes to this side is equal to BC square. So BC square is equal to 168. So BC is equal to 9 centimeter. So you got BC. Now what you need? Area of triangle ABC. What is area of triangle? Any triangle, right angle triangle? It is half into base. What is the base over here? BC. What is the height over here? AB. It is half into base into height. So it is half into BC you got as 9 and AB is given as 12. So 2 6 it is 54 centimeters square. Now you got both the fill-ups. Let's use this. So this will become of triangle AED upon ABC you got as 54 is equal to DE is 3 square, BC you got as 9 square. Okay, let's continue. So this I got as 9 centimeter. Yeah. So area of triangle AED upon 54 is equal to 3 square is 3 into 3 which is 9. 9 square is 9 into 9 which is 81. You can cut this. This is 1 upon 9. So area of triangle AED will be equal to 54 into 1 which is 54 divided by 9 which is 6 centimeter square. This is what you have proved the second subpart. Now let's go to the third subpart. The third subpart you want is prove that area of quadrilateral BCED. First let's find area of quadrilateral. How do you get area of quadrilateral? BCED will be area of triangle ABC minus area of triangle AED. Correct? Now area of triangle ABC you've already got as 54 centimeter square and area of AED we have already proved it is 6 centimeter square. So area of quadrilateral 54 minus 6. What is 54 minus 6? 48 centimeter square. Now let's substitute this. Area of quadrilateral BCED upon area of triangle ABC. What is this? This is 48. What was triangle ABC? It was 54. Okay. 8 8s are 6 9s are. This is what you were supposed to prove. You got area of quadrilateral BCD upon this is 8:9. Okay. I end this video here. Please stay connected for the next part. Till then, bye. Take care. God bless.